Good day, good morning, good afternoon. Today, or in this video, we will be talking about two and three-dimensional motion. So in the previous video, in the previous discussion, we talked about motion in horizontal direction as well as vertical direction. But as we know, in real life, motion doesn't just exist na horizontally or vertically. So sometimes motion can happen in two and three dimension. So that's what we will be talking about. So for example, when we bat something, what determines where a batted baseball lands? So di ba dili lang man na siya moingon nga diretso lang og igo. So sometimes they will di ba ilang i-hit in such a way nga move siya ana nga direction. But like when you hit something, what will determine na diri ni siya dapita mo land ang ball? Or if a cyclist is going around a curve at constant speed, can we say that the cyclist is accelerating? So go siya around a curve and then the speed is constant. Is he accelerating or not? So in our previous lesson, we have learned that the motion of a particle along a straight line is completely known if its position is known as a function of time. So diba, we used the kinematic equations to to like describe the motion of a particular object. So the relationship between speed, distance, time. So this time we will now extend this idea to a two or three-dimensional motion of a particle in the XYZ plane. To describe the motion of a particle in space, we must first be able to describe the particle's position. Okay, so for particle P, which is here, so this is position of particle P at a given time, which has coordinates x, y, z. So this is the position vector of particle P. Okay. So the terms that we are going to be using now is instantaneous velocity. So it's the instantaneous rate of change of a position with respect to time. So if for an XYZ plane, so na siya x nga component, y nga component, z nga component. So same with instantaneous velocity. For the average acceleration during a time interval delta t, it's defined as the velocity change during delta t divided by delta t. So same thing that as we have discussed. So this is a car moving around a curve. So this car accelerates by slowing while rounding a curve. So its instantaneous velocity changes in both magnitude and direction. So lahi ang velocity diri nga point, lahi po siya ang velocity nga point. So we can say that it is decreasing, ni decrease, ni slow down siya, kay ni gamay man ang velocity nga vector. So to find the car's average acceleration between the 2 points, so P1 and P2, we just find the change in velocity by subtracting V1 and V2 and then find the acceleration by dividing it by delta t. So the average acceleration has the same direction as the change in the velocity. Okay, and then we have instantaneous acceleration. So the instantaneous acceleration is the instantaneous rate of change if the velocity with respect to time. So diba, as we have discussed, it's the limit of delta v over delta t as delta t approaches 0. So we are just going to make delta t approach 0 because we cannot find the velocity or the acceleration if we just divided this by 0. So undefined set. So we are just going to find the value which this ratio approaches. So it's important to note that any particle following a curved path is accelerating even if it has a constant speed. Okay, so for the direction of the acceleration vector, so the direction of the acceleration vector depends whether the speed is constant, increasing, or decreasing. So when the speed is constant along a curved path, so this would be the direction of the acceleration vector. So to answer the question is if mo follow sa curve na path, may change in direction, and then same constant ang speed. So the question is, nag-accelerate pa siya? So the answer is yes. Okay, na may change in direction. So remember that acceleration is a vector quantity. So when speed is increasing along a curved path, so this would be now the direction of the acceleration vector. And when it is decreasing along a curved path, so this would be the direction of the acceleration vector. Now let's go to projectile motion, so 2D. A projectile is any body given an initial velocity that then follows a path determined by the effects of gravity and air resistance. So like for example, in this photo here, so we have a dolphin. So whenever a dolphin jumps out of the ocean or the sea, it follows a path called a projectile. So ang motion sa dolphin is projectile motion. So there are two assumptions when we deal with projectile motion. So first, free fall acceleration is constant over the range of motion and is directed downward. So this free fall acceleration is the acceleration due to gravity. And we also assume in projectile motion that the effect of air resistance is negligible. Diba? Like ideally, if you have a paper and a ball, they have different masses. So ideally, if wala air resistance, I don't know if you have seen a video of this when I experiment ng gitang-tanggal ang air resistance. So regardless of their masses, even if the paper is light and the ball is heavy, when you drop them without air resistance, they will reach the ground at the same time. But in real life, because of course air resistance is present, so we would expect that also with the surface, no, papel nga naon, mas dugay gid maabot si papel sa floor, depende kung asa siya doon sa hangin. But here in projectile motion, we assume that the effect of air resistance is negligible. So with the assumptions made, we find that the path of a projectile, which we call its trajectory, is always a parabola. So a projectile na path, the trajectory of a projectile is parabolic. So a projectile moves in a vertical plane that contains the initial velocity vector v sub o, but in some cases we use v sub I. Its trajectory depends only on the initial velocity and on the downward acceleration due to gravity. So again, its trajectory depends only on the initial velocity and the acceleration due to gravity. Projectile motion is confined to a vertical plane determined by the direction of the initial velocity because of the acceleration due to gravity, which is purely vertical. So gravity cannot accelerate the projectile sideways. So bisan pag initially gipadong siya dito, so eventually it will just go down because there is a factor that is causing it to go down. So analysis, therefore, of a projectile motion is a combination of horizontal motion with constant velocity and vertical motion with constant acceleration. So kung horizontal ang motion, so for a projectile na ay horizontal o vertical motion, diba? That's why ang anang iyang path. So sa horizontal na motion na part, constant ang iyang velocity. Constant ang horizontal component sa velocity. Okay? But for vertical motion, ang constant kay ang acceleration. Meaning, ang vertical component sa velocity mo change na siya as the object follows its trajectory. Okay. So we can see here, so from this picture, we can see that the horizontal component of the velocity is constant. So kung sa initial na horizontal component dire sa initial velocity, that would still be the same inigland niya o balik. So as the object would go up, so constant na, same ra na ang iyahang horizontal component, but the vertical component of the initial velocity as it will go up will be decreasing until inigabot niya sa highest na point sa trajectory. Vertical component of the initial of the velocity would now be 0. So ang diri sa topmost na portion, ang nakabili na lang ang horizontal component. And then as it goes down, mo anam na pod og ka-increase ang magnitude sa iyahang vertical component, pero this time it is now directed downward. Okay. So the initial velocity components of a projectile are the horizontal component and the vertical component. So VO sub x and V sub OY, or we can sometimes use I for initial, no? So these components are related to the initial speed, V sub O, and the initial angle, theta. Or this initial angle can be, we can use launch angle for this. So that VOX equals VO cosine theta. So from this, diba, sa ato ang dissolve sa vectors into two components. So the horizontal component would be the velocity times the cosine of the launch angle theta, and the vertical would be VO sine of theta. So for the horizontal component of motion, okay, horizontal velocity at any time t would be V sub x, which is just equal to VIX, so initial, or VOX. The horizontal component of the velocity is constant, as I said, at any time t. Therefore, Vx is equal to Vox or Vix, which is equal to Vi cosine theta or Vo cosine theta. Again, so the subscript O can be replaced with I, and that is for initial, and theta is the launch angle. And to find the horizontal distance of the object from the initial point at time t, so x would be vxt. So asa man siya gikan, this is just velocity equals distance over time. So x now is the distance, horizontal na distance. So at any point, we can find kung saan na yung horizontal distance na travel using this formula at any time t. So we can just replace vx with Vox, they are just equal, or we can replace that with Vo cosine theta t. So again, kani silang tulo, they are just equal. Kay constant man ang horizontal component sa velocity all throughout the motion of the object. Now for the vertical component, since it is affected by gravity, so dili siya constant. So at time t, the vertical component is given by, so di ba katong kinematic na to nga equation. So V, that would be the final velocity, equals the initial velocity plus gt. So V equals VO. V is the velocity at time t equals the initial velocity plus g of t. But this is now again for the vertical component, so sub y. So Vy equals Voy or Viy plus gt. Vy equals Vo sine theta plus gt. At time t, the vertical distance of the object would be, so at time t, muna ang iyahang velocity, kung pila na ka-seconds ang nilabay, muna ni ang vertical component sa velocity sa object, and we can also find its vertical distance. So at time t, asa naman siya dapita sa projectile? Is it still going up? Or niabot na ba siya sa iyang maximum height? Or padong na ba siya ubos? Padong na ba siya balik sa ground? So y equals, so diba, y equals vit plus 1/2 gt squared. So that's basically this one. So y equals v sub oyt plus 1/2 or 0.5 gt squared. Or that's y equals vo sine theta t plus 0.5 gt squared. Okay, so what is time of flight? The time of flight is the time na ni total siya, bali, from the total time of flight, basically from when it was launched to the point na nibalik siya sa ground. So the time at which an object in projectile is on air is only affected by the vertical component of the motion. So again, as long ang time nga ang factor nga naka-cause niya nganong ingana siya kadugay na mo stay on air, like the time it would take for this object to reach this position, or the highest point, or maybe go back to the ground, the factor that only affects it is the vertical component of the motion. So again, walay labot si horizontal. So if we let T sub max be the time when the object reaches its maximum height, okay, maabot siya sa highest na point. Now remember, igabot sa highest point sa object, the velocity, the vertical component of the velocity there is 0. So then T equals negative VI y over G, or negative VI sine theta over G. Ito maning V equals VI velocity initial plus GT. Okay, so time therefore is negative VI sine theta over G. Okay, so dinha na siya gikan. And the total time of the flight will be, okay, that's just twice that T. So total time of flight, we're going to use the capital letter T to represent the total time of flight. So basically, class, when an object is in projectile, so the time for the object the time it would take for the object to reach the maximum height would be the same time it would take for the object to reach the ground from the maximum height. So if you have the time, if you're able to compute for the time it would take for the object from the launch to reach its maximum height, so that you can just multiply that by 2 and then you will be able to get the total time of flight. Again, the total time of flight would be the time from when the object was launched to the time that it goes back to the original level kung asa siya gi-launch. That's total time of flight. Okay, so we now know how to find the time of flight and the time for the object to reach the maximum height. Now we will be learning, or we find now the maximum height. So unsay pinakataas na height na ma-reach sa object? So the maximum height of the projectile is the highest vertical position it can attain along its trajectory. So what are the factors that affect the maximum height? Of course, again, the initial velocity, the launch angle, and the launch angle. So since velocity is 0 at the highest point, so the velocity that I'm talking about here is not the resultant velocity, but we are just kay vertical man siya, height man siya, we are just talking about here the vertical component of the velocity. Okay? So remember, wala gina siya na 0 ang velocity niya. Okay? Ang ma-0 lang ang horizontal component sa velocity. Kay ang vertical component sa velocity, kay ang horizontal component na ang gyapon na siya all throughout the path, all throughout the trajectory, the horizontal component is constant. So since the vertical component of the velocity is 0 at this point, so we can find the maximum height as solve for the maximum height as negative VI sine theta squared over 2G. So asa na siya gikan? VF squared equals VI squared plus 2GY. Itong kinematic na equation. And then for the horizontal range, so the range would be, balik ta, so katong horizontal nga motion, so the range would be the distance from where the object was launched to the point kung asa siya nibalik sa same level kung asa siya gi-launch. So the horizontal range, so we use a capital letter R to represent the horizontal range of a projectile, is the maximum horizontal distance it travels as it returns to the same horizontal level from where it was launched. So range would be, so di ba ang distance is x equals BO cosine theta t. So t here, at time t, muna ni ang horizontal distance na na-cover sa object. But since we're talking about the range, the maximum, so di ba maabot siya ana nga range kung sa iyahang total time of flight. So we are just going to replace small letter t with a capital letter T, and we're just going to replace the small letter x with the capital letter R to indicate na range na siya. And then we're just going to substitute t here with the formula for finding the total time of flight, and we derive the formula, so that's negative VI squared sine 2 theta over G. Okay, so that is for the range of the object. Now let's go to the launch angle. So projectiles launched at the same initial velocity and with complementary launch angles will attain the same horizontal range. Okay? Complementary, ang sabi ng complementary, when you add them, it would equal to 90 degrees. So as long as the initial velocity is kept constant, so this is the pattern sa range na ma-reach sa projectile. So they will have the same horizontal range. So may 75 degrees. So may complement sa 75, we have 15. So ma-reach siya ng same na level. Ang 60 ug ang 30, same. So ang pinakataas og range nga atong ma-expect would be 45 degrees, again provided that they have the same initial velocities, all of them. Because of course it would matter po kung unsay initial velocity. They will, however, have different maximum height and the time of flight. So ang range lang ang magpareha for complementary launch angles of same initial nga velocity. So for example, a long jumper leaves the ground at an angle of 20 degrees above the horizontal and at a speed of 11 meters per second. So we are asked to find how far he jumps in the horizontal direction. So meaning we're looking for the range in letter A and we're looking for letter B, what is the maximum height reached. So just remember that in solving problems, we have to identify kung sa'y given and also we have to know what we are looking for. Okay. And of course, it would help if you would draw. So our initial velocity is 11 meters per second. So let's say that you don't really have to draw the long jumper. So it leaves the ground at an angle of 20 degrees. So of course, when he jumps or she jumps, ang iyang path would follow that of a projectile. So muna iyang trajectory. So ang pangutana, how far does he jump in the horizontal direction? So letter A, we're looking for the range. And letter B, what is the maximum height? So all we need to do is to use the formulas that we were able to derive a while ago. So for the range, it's negative di squared sine 2 theta over g. Okay, so our initial velocity is 11 meters per second. So don't forget to raise that to the power of 2 and take the sine of 40 degrees and then divide it by 9.81 meters per second squared. So take note that we're putting here a negative sign because asa man ang direction sa G, diba? It's always downward. So let's keep in mind na ang atong convention ani positive ang padung saka, negative ang padulong ubos. So negative 9.81 meters per second and we have an answer of approximately 7.9284 meters ang iyahang range. For letter B, the maximum height reached, so we are just going to use the formula, negative di sine theta, quantity squared over g, and then substitute. So this is just a matter of knowing how to input these values in your calculator. And so we have the maximum height of approximately 1.4428 meters. So you have to, of course, make your conclusion when you write your answers. Number 2, a batter hits a baseball so that it leaves the bat at a speed of 37 meters per second and an angle of 53.1 degrees. So it's basically the same thing as the previous problem. We are given the initial velocity or speed na 37 meters per second and we are given also the launch angle, which is 53.1 degrees. So letter A, we're now going to find the position of the ball and its velocity after 2 seconds. We're now going to find the time when the ball reaches the highest point of its flight. So, balik ta. In letter A, when you say position, we will be looking for its horizontal and vertical distance, na iyang na-cover, and of course, the velocity, pag abot niya 2 seconds. For letter B, we're looking for the time when the ball reaches the highest point, and its time of its flight, and its height at this time. So, maximum height, ug ang time nga maabot siya din ng height. And then letter C, we are to find the horizontal distance from the starting point when it is 20 meters above the ground. So pila na ang iyang horizontal distance na na-cover kung ang ball kay 20 meters above the ground. So let's answer them one by one. So we're given the initial velocity 37 meters per second, and we're given the launch angle of 53.1 degrees. So for letter A, we are to find the position of the ball and its velocity after 2 seconds. So its position is it is now iyang vertical distance after 2 seconds would be, we can use the formula y equals vi sine theta t plus 1/2 gt squared. So we can just substitute there. So that's 37 meters per second times sine 53.1 times 2 seconds plus 1/2. And just remember na ang atong motion is going up, that's positive, but our acceleration is directed downward. So dapat na ay negative. So minus 9.81 meters per second squared times 2 seconds squared. So y equals, ang iyahang vertical distance na is now 39.5567 meters. But we still have to find its horizontal distance na iyahang na-cover. So for horizontal distance, so for x, unsa man to'y formula nato sa x? X equals the vxt. Velocity is distance over time, but vx is equal to voxt. And voxt is vo, that's initial velocity, or vi. I'm using I here. Vo, and that's cosine theta t. So we can just substitute the values. The initial velocity is 37 meters per second. Cosine of 53.1 degrees times 2. So we can use our calculator. So horizontally, ang iyahan nang na-move kay after 2 seconds, it's now 44, yung horizontal, 44.4311. Approximately 44.4311 meters. Muna nang iyang na-cover. Okay, balik kung muna siya ang projectile, it would now be, so probably somewhere here. So muna siya ang 39.5567 na. Kani siya ang 44.4311 meters. So muna ang iyahang position. And then we've the velocity. So for the velocity, diba, v is equal to vi sine theta plus gt. This is for the vertical component. So vf is equal to vi plus gt. So this is 37 meters per second sine of 53.1 degrees plus negative 9.81 meters per second squared times 2 seconds. So this is again for the vertical. So ang iyang vertical component sa velocity diri nga part, okay, yung vy din nga part is equal to, again we are going to use the calculator. So 37 sine 53.1 so its vertical component is approximately 9.9683 meters per second. And then for its horizontal component, Vx, so Vx equals Vi cosine theta, Vi cosine theta, so that would be 37 meters per second times the cosine of 53.1 degrees. So our Vx would be so that's approximately 22.2155 meters per second. Okay, but we do not end there because we have to find the resultant velocity. So velocity resultant would be the square root of our Vy squared plus Vx squared. So kanisha is square plus kanisha is square, and then we extract the square root. So that would be the velocity of the object ani ni nga position. So na Vy of Vx here. So we would expect, kanina nisaka naman siya, we would expect that its velocity at this point would be, of course, less than 37 meters per second. So we're going to raise our answer to the power of 2 and add it to the Vy squared and extract the square root. So our answer is approximately 24.3495 meters per second. So it's now less than 37 meters per second. So these are our answers for letter A. So it's vertically, it's now 39. So it's now 39.5567 meters above the ground. Horizontally, 44.4311 meters from its launching position, and its velocity is now 24.3495 meters per second. Okay, so letter B, find the time when the ball reaches the highest point. So we're just going to use the formula discussed. So we're going to use T equals negative VI sine theta over G. So all we need to do is to substitute the values. So negative 37 meters per second, sine 53.1 degrees. Again, please use negative 9.81 meters per second squared because it's directed downward. So it will take approximately 3.0161 seconds for the object, for the baseball to reach the maximum height. And the maximum height we solve is, we use the formula negative VI sine theta quantity squared over 2G, and we'll be able to get the height 44.6213 meters. So, ang iyang maximum height kay, so na siya diri dapit. So, it would take T maximum to reach this point, and this is now the maximum height. Okay. So, next, letter C. We are to find the horizontal distance from the starting point when it is 20 meters above the ground. So in the previous letter B, we were able to find out na iya maximum height na ma-reach kay 44.6213. So meaning 20 meters, okay, almost halfway pa siya. So naay duha ka points nga it is 20 meters above the ground. Katong pasaka pa siya o katong paubos na. So, we need to solve unsa man ni siya nga horizontal distances. So, x equals bi, remember that x equals bi cosine theta t. So, first, ang time before siya naabot sa iyang maximum height, o ang second nga time nga naabot siya sa, nilapas na siya sa maximum height. And how do we find this time? So, we're going to use the formula y equals bi sine theta t plus 1/2 gt squared. Kaya sa may given na to, nga 20 meters man daw siya above the ground. So we were able to come up with quadratic na equation. So just substitute na ang y na to is 20 meters, ang atong initial velocity kay 37 meters per second, and then sine of our launch angle 53.1 degrees, and then our unknown variable is t. So plus 1/2 times negative 9.81 meters per second squared times t squared. And then we can just input these values in our calculator, press mode equation 5, press mode 5.3, and then input. So we'll be able to come up with these two values. So, ang kanina 5.26, of course, kanina ning panaog na siya. Ang kaning 0.78, mauni siyang pasaka pa. So at p equals 0.78, we solve for its horizontal na distance. So we are able to get approximately 17.23 meters. So mauni siya nga distance. O pag abot sa 5.26, it's now 116.78 meters horizontally from its launch nga, from the starting point or from the launching nga position. Okay, example number 3. You throw a ball from your window 8 meters above the ground. When the ball leaves your hand, it is moving at 10 meters per second at an angle of 20 degrees below the horizontal. So, ang atong gi-ano diri nga ang movement paubos na. It's now directed downward. So, how far horizontally from your window will the ball hit the ground? Okay. So, let's say that your window is here, it's 8 meters above the ground, so it's now directed downward. Okay. So, ang atong kitangita, pila horizontal distance from your window nga niabot siya sa ground. So, we have the initial velocity and our launch angle is 20 degrees, but it's now paubots. So, first we solve for the time when the ball will reach the ground. So, for us to be able to solve for the time that the ball will reach the ground, we use the same formula that we used in the same problem. So y equals bi sine theta t plus 1/2 gt squared. But if you will notice here, ang akong gigamit kay positive 9.81 ni. Okay. Because ang akong gigamit na nga y diri is now gi-positive na nako ang directed downward. Nga naman kay paubos naman sila tanan. Okay? So ako siyang pero it will still change if pwede ra gyapon nga atong himuon nga positive ang saka. Okay. So ang atong basihan would be our reference point. Okay, mo ni siya atong 0. So since kung kani atong reference point, so therefore ang kani diri negative na ni ang y diri, di ba? Kay kani man atong reference point. If this is now there paubos ang iyang velocity, okay, initial velocity would now be negative 10 meters. Ang iyang vertical na component would now be negative. Okay, not really negative 10, sorry. Ang iyang vertical component would now be negative, paubos. Right? So, kung i-substitute na to ang atong formula ani, it will now be negative 8, okay, equals, we'll still substitute 10 meters per second, sine of, alright. So, sine of, so kung kani atong launch angle mo ni 20 degrees, di ba? Counterclockwise. But if our angle is clockwise, the angle should be negative. So, mahimo na siyang sine of negative 20 degrees. T plus 1/2 negative 9.81 t squared. And yeah, sine of negative 20 is just equal to negative sine of 20. So basically, makancel na tanan natong negative signs. May muli siyang negative 8, negative 10, sine 20 degrees t minus 1/2 times 9.81 t squared. So makancel na tanang negative sign, so muli gihapon nato diri sa poles positive. It's the same concept. So ang ako lang gibuhat diri initially is gihimo na ko siyang positive na tanan because all movements are now directed downward. Ang ihang y is paubos, ang ihang velocity is paubos, ug ang g kay paubos. So bala gi-cancel na lang tanan negative. So using the calculator, we'll be able to come up with these two values. So one is a negative nga value. Of course, there is no negative nga time. So that's an extraneous nga root. So ang time nga atong ang gamiton ra kaning 0.97519 blah blah blah. And then we are going to substitute this now to the formula for x, which is equal to vi cosine theta t. And we'll be able to solve the horizontal distance, which is 9.16 meters from the building. Okay, number 4. A rookie quarterback throws a football with an initial upward velocity component of 12 meters per second and an initial horizontal velocity component of 20 meters per second. And we are supposed to ignore air resistance. So in this example, what's different from this example sa uban examples is that we are not given the launch angle. We are not given the initial velocity dion, but we are given the components of the initial velocity, the vertical and the horizontal components of the initial velocity. So we're asked to find the time required for the football to reach the highest point of the trajectory, the maximum height for letter B, letter C, the time of flight, and letter D, the range. So we can just use the formulas derived for all of these letters. It's just that we need the initial velocity and the launch angle. So it's very easy because we have the vertical and the horizontal components of the initial velocity. So we can just use this, diba? So resultant, using the component, the resultant would be the square of the sum of the square root of the sum of the squares of the two components. So you just raise the upward component raised to the power of 2 plus the horizontal component raised to the power of 2 and extract the square root. And we'll be able to solve the initial velocity, which is equal to exactly 4 square root of 34 meters per second. And then we can solve for the launch angle, which is arctan of the vertical over the horizontal component, and we'll be able to come up with 30.963755653 degrees. So launch angle. So we now have the initial velocity and the launch angle, so we can now solve for our unknowns. So for A, the time to reach the maximum height, so T max. So we just use the formula, substitute the values that we were able to come up with, and we're able to find that it's 1.22 seconds. And then letter B, the maximum height would be, of course, we just use the formula again, substitute the values. So initial velocity, the launch angle, and the acceleration due to gravity. So we'll be able to come up with 7.34 meters. The time of flight, you can just multiply your answer in letter A by 2. That would be the time required for the football to return to its original level. And for letter D, the range, again, we are just going to use the formula derived and then substitute the values. So we'll be able to come up with 48.93 meters. So just know your formulas, and just know what the variables mean, and just know when to use them. Okay, for the last example. A stone is thrown from the top of a building upward at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second. So you're on top of a building, you stow a throne directed upward, 30-degree angle, and the initial speed is 20 meters per second. The height from which the stone is thrown upward is 45 meters above the ground. So it's basically, let's say, for example, kung gikan reach sa top sa building, let's say that the height of the building is 45 meters. So when you throw the stone upward, it doesn't go back to the top of the building, but instead it will go to the ground below the building. So letter A, the question is how long will it take the stone to reach the ground? And letter B, what is the speed of the stone just before it reaches the ground? Right, so this would be, you really have to learn how to interpret the problem, make a drawing, because it will help you understand. Drawings are required. If you don't draw, your variables are all meaningless. Okay, so take note, we take the top of the building as the reference point. So our y would now be negative. So dili na nako tangtangon ang negative nga naman, because not all of the direction is directed downward. So ang initial velocity pasaka na siya. So how long will it take for the stone to reach the ground? So the vertical distance na of the stone would now be 45 meters below the top of the building. Muna siyang negative 45. So we again use the formula that we have used in the previous problems, which relates the vertical distance and the time and the initial velocity and the launch angle. So negative 45 meters equals our initial velocity, sine of the launch angle, times t plus 1/2 negative 9.81 meters per second squared t squared. So again, we use our calculator and we'll be able to get an extraneous variable, extraneous value. So we don't use this. There is no negative time. So we're going to use P1, which is 4.22 seconds. So it will take around 4.22 seconds to reach the ground. Okay, and then what is the speed of the stone just before it reaches the ground? So when we say speed, again, it should be the resultant of the vertical and the horizontal component. Remember that it's projectile, so the horizontal component of the velocity will just be constant. So first, we'll solve for the horizontal component of the velocity. So that's 20 cosine 30 degrees. So that's 10 square root of 3 meters per second. So all throughout the trajectory, the horizontal component would just be 10 square root of 3 meters per second. Okay, and then we'll now be looking for the vertical component of the velocity just before it reaches the ground. So we can use this formula, Vf squared equals Vi squared plus 2Gy, or you can also use Vfy equals Diy plus Gt. This is another option, and definitely it will just give you the same answer. Okay, na naman tayo time, diba, for it to reach the ground. Pero for me, I am using this because just in case nasayop akong time gisolve sa letter A, dili mapagan akong answer sa letter B. So it would be best to use the values given instead of the values that you were able to solve. Kung pwede lang. Okay, so Vfy therefore is the square root of Viy squared plus 2Gy. So our initial velocity, the vertical component of our initial velocity, so that's 20 sine 30 raised to the power of 2 plus 2 times g, which is negative 9.81 meters per second squared, and y is now negative 45 meters. So again, it's negative 45 because it is below our reference point. So, ubos siya sa building. So, solving using our calculator, we'll be able to come up with this value. So 31.3512360 meters per second. So we now have the horizontal and the vertical component of the velocity just before it reaches the ground. And now we can solve for the resultant of the two. And so raising the vertical component to the power of 2 plus the horizontal component to the power of 2. And we extract the square root. So the speed of the magnitude of the velocity, or the speed of the stone just before it reaches the ground, is 35.82 meters per second. And of course, it has to have a direction. So asa man siya directed? So may direction ni. So ang katong velocity would be paana na siya diha. So this is the horizontal component, and the vertical component would be directed downward. Okay, so that would be it for projectile motion, and so you're supposed to answer the activities.